sklearnmetricsmatthewscorrcoef. Description: the Matthews correlation coefficient (MCC) is a measure of the quality of binary two-class classifications. It takes into account true positives Tp, true negatives Tn, false positives the, and false negatives Fn. Inputs: y true, the true labels of the data, represented as a 1D array of binary values 0 or 1. Y pred, the predicted labels of the data, represented as a 1D array of binary values 0 or 1. Outputs: MCC, the Matthews correlation coefficient, a floating point value between -1 and 1. Steps: calculate the number of true positives Tp, true negatives Tn, false positives the, and false negatives Fn from the true labels y true and predicted labels y pred. Calculate the Matthews correlation coefficient using the formula MCC/TP/Tn, or FN/SQRT/Tp a TP/Fn/Tn a Tn fluorine mononitride. Metrics: accuracy, a measure of how often the classifier correctly predicts the labels. Precision, a measure of how often the classifier correctly predicts positive labels when it predicts a positive label. Recall, a measure of how often the classifier correctly predicts positive labels out of all actual positive labels. F1 score, a harmonic mean of precision and recall, providing a balanced measure of the classifier's performance. Visualization plots. Confusion matrix, a visualization that shows the number of true positives, true negatives, false positives, and false negatives. ROC curve, a plot that shows the trade-off between the true positive rate and the false positive rate for different thresholds. Fine-tune parameters. None. The Matthews correlation coefficient is a single value that does not have any tunable parameters. Uncertainty methods. None. There are no specific uncertainty methods associated with the Matthews correlation coefficient. Challenges and fixes. Challenge 1: imbalanced datasets can lead to misleading MCC values. Sample use case: if the dataset has a large number of negative labels and only a small number of positive labels, a classifier that always predicts negative labels might achieve a high MCC value, even though it is not actually performing well. Fixes: use techniques to address class imbalance, such as oversampling, undersampling, or using weighted loss functions. Challenge 2: the MCC value can be sensitive to small changes in the number of true positives, true negatives, false positives, and false negatives. Sample use case: a small change in the number of false positives could result in a significant change in the MCC value.